Good morning, everyone. I am Swapnil Sravne, student of Computer Science and Engineering, second year department. Welcome you all in this faculty development program on blockchain technology. Blockchain increases trust, security, transparency, and the traceability of data shared across a business network. Let's start by getting to know our expert for today's session, Dr. Maheshwari Raja. She is a professor and HOD of Computer Science and Engineering Department, certified professional secretary at Vellore Institute of Technology at Chennai, Tamil Nadu. She has completed her Bachelor of Engineering in Computer Science and Engineering from Government College of Engineering, Tirunelveli in 1997, followed by the MTech in Embedded System and Technologies from College of Engineering, Anna University, and her PhD in Computer Science and Engineering from Vellore Institute of Technology, Chennai. Her area of interest is in IoT, that is Internet of Things, smart grid technology, blockchain, data analytics, and machine learning. She has worked on various consultancy projects, and currently her ongoing consultancy project is on dynamic website development and deployment. She has also published various books on the ongoing technology. She has been awarded as an Outstanding Contribution Award for mentoring students in ISM by FSSE-IT Bombay in the year 2022. And today she will be telling us about unblocking the blockchain. So without further ado, I would like to hand over the session to Dr. Maheshwari Raja.
Over to you.
Thank you, Sister. Thanks for your warm welcome. Am I audible?
Yes, ma'am.
Thank you. I'll just share my screen. I think you have to give privileges to share my screen. I couldn't find an option to share my screen. Can the organizing team?
Just a minute, ma'am. Just a minute.
Yes, I could present.
Can I go host, ma'am?
Is my screen is visible? Is my screen visible?
Yes, ma'am.
Yes, thank you. Thank you, the organizing committee, for the opportunity, and thank you for the learners. Now let us start our session in unblocking the blockchain. Your learning perception has started from yesterday, I guess, during this FTP. So this will be the agenda. We'll learn about what is a Bitcoin, what is all about blockchain technology, smart contract, solidity, and we'll write a few contracts using Ethereum IDE. And we have done some projects and the research work using blockchain. So I'll give you some demo on the hands-on of the blockchain. So this will be the just a glimpse idea about the blockchain agenda of today's session, unblocking the blockchain. So I would like to have an interactive session. Let me not be a distributed one. We'll have it's called peer-to-peer. So we'll have an acknowledgement session, unblocking the blockchain. Last one day you might have learned about blockchain. Can you just get it in the chat box, or can you unmute yourself and tell me what you are learning in the blockchain technology in the last one day? Any answers in the chat box? Is chat box is available to everyone, ma'am? Yes, thank you. Thank you, Priya. Thank you, Priya, ma'am. Thank you for your early response. What is your learning? It might be a simple thing. Okay, just put it in the chat box that what is your learning in unblocking the blockchain, or what is your learning in the blockchain in the last one day? I'll happy to hear your voice or happy to see your messages. We are doing a faculty development program, I guess. If a faculty is finding difficult in getting answers from another faculty, you think about how the communication happens between a faculty and a student. Okay. So I believe all my faculties will help us to create an interactive session in for today's learning. Whatever you learned, let it be a block, it can be a chain, or what terminology you learned in yesterday's session, or what are the topics you learned about, you know about the blockchain, the terms which you know earlier about the blockchain. I could have. I need some answer from your end. I'll be happy to see your chat boxes. Thank you, Priya ma'am. Thank you so much, Priyanshi ma'am. Thank you. Consensus algorithm, great. So you might have heard about this consensus algorithm. It plays a vital role in taking decision of adding your blocks to your blockchain. Great, ma'am. Uh, any other learners, community, the faculty, dear faculty learners? Okay. So I'll just through you just see whether you heard about these terminologies, Bitcoin and the blockchain, and you might have heard about hash SHA-256. If not, we will have a groundwork here. Genesis block, distributed ledger. So when we talk about blockchain, these are the terms which comes into the mind: public and the private blockchain, public cryptography, Ethereum, consensus algorithm, as ma'am said, Priyanshi ma'am said, yes, consensus algorithm, the proof of work concepts, remix IDE, and then the smart contracts. Okay, these are the promising keywords which got associated with the blockchain, and these are the words today we are going to unblock it. Okay, so the terminology which being popped here is going to be unblocked here to this technology and to this session unblocking the blockchain. So apart from that, we are going to see what is all about the 51% attack, the Merkle root, the norms, all these things we are going to look into it. So before I start, since I didn't get any answer from my participants, I'll just start from glimpsing the few idea about what is a Bitcoin. It is a new currency, internet currency. This Bitcoin is a peer-to-peer internet currency. So you could see this is a peer-to-peer internet currency that allows decentralized transfer. Okay, that is very important point. Decentralization is a backbone of this blockchain technology. It transfers value individuals and the businesses. That is one point about the Bitcoin. And the second point about the Bitcoin is it is a distributed one. Okay, that is what it is, decentralized, and it ensures the digital currency system. Okay, it ensures a digital currency system. And one more thing is, it was not backed by any government or organization. That is another asset to the blockchain. It does not be backed. So far, it was not backed entirely by the government or the organization, and it creates an instantaneous peer-to-peer transaction. It always allows an instantaneous peer-to-peer transaction, and we no need to give something for the third party. No need for a trusted third party. Third party role is completely eliminated. That is what a blockchain plays. It gains a market nowadays. Okay, so this third party intervention is avoided completely, and it provides a cryptographic security as well. That is another asset added to this the concept. And we have the low cost banking for everybody. It ensures banking for everybody and everywhere across the currency denominations, which varies from country to country nowadays. Now it gets been replaced with this equality in the currency parameter with this blockchain. So money for the information economy. We can say this Bitcoin is going to be a money for the information economy. So the way there is no authorities being formed, or there is no regulator, it's a permissionless. Okay, there is no frozen funds happens in this blockchain. Okay, so we can have it 24 cross 7, 365 days. You can access it. Okay, borderless. There is no geographic limit for this Bitcoin, and the transaction cost is negligible when compared with other banking sectors. Okay, it creates a transactional and no specific jurisdiction applies. It secures and resilient. These are the major points which adds value to this Bitcoin. Okay, you might have heard about him, Satoshi Nakamoto. So he is the backbone of this. Okay, so he created an electronic payment system in 2008. In 2008, he created this platform, an electronic payment that is based on cryptographic proof instead of trust. Okay, so he thought that a e-platform has to be created, okay, across the globe in order to have a uniform in the money perception, okay, in the monetization perceptions. Okay, that is what this Bitcoin has come into the picture. And we have, you might have seen, or if it is new to you, you just keep understanding, have an understanding of it. You have a wallet here. Every Bitcoin will have a wallet. This wallet will hold these information. It have the user accounts, it will have the address and the Bitcoin amount. Okay, every wallet of the Bitcoin will have this, either in multiple layers of the trees. Okay, so user accounts, addresses, and the Bitcoins. So at any level you track it, the three important criteria which going to add the value to the Bitcoin wallet is wallet, user account, addresses, and the Bitcoins. So now we know, we might have learned this terminologies in yesterday's session as well. Blockchain. So this blockchain is an open. Okay, as the welcome address, we specified that it is a distributed. Yes, it is a distributed. Blockchain is an open distributed ledger that can record a
Open basic
transaction between
ideas.
two parties efficiently in a verifiable and permanent way. Permanent way, it's very, very important. It is immutable. You cannot revoke it. Okay, since we are working with money, okay, it's very important to have this permanent evidence. Okay, so this blockchain gives us its open distributed ledger. It can record transactions between two parties efficiently in a verifiable and permanent way. Okay, the terminologies which get associated with the blockchain is the DLT, distributed ledger technology. Okay, so ledger you might be heard about. We have like books. Okay, so here the book is going to get distributed. That is what the name got, distributed ledger technology. So it permits transactions to be gathered in the blocks and records. So what is going to make it? It's going to create the transaction in terms of blocks. So blocks, it's going to create a blocks in terms of transactions. Every block will have a data and the addresses are, it's called addresses associated with it. So it creates a link in order to make this blockchain. So block, as we might be observed, blockchain is going to hold a block. That block is going to contain two important parameter. One is the data and the address. That is a reference here. Okay. Um, so this is the history of blockchain. I'll just post this in the chat box so that everyone could observe this. How many of you using laptop or a mobile? Can I get a L or M in the chat box at least for this question? L, if you're using laptop, you can type L. If you're using mobile, you can type M. Thank you, Professor Jyoti. Thank you. You're using laptop. Thank you for your kind response. If you're using laptop, type L. If you're using mobile, kindly type M. Thank you, Jyoti ma'am. Preeti ma'am, thank you so much. You're using mobile. Sonali ma'am, thank you. You're using a laptop. Good. Thank you for your interaction. Good. So now, if you're using a mobile or laptop, you just go through this website. So, history of Bitcoin. Even you can give this demo to your students. So students could understand it in a better way. How this Bitcoin of the history of the Bitcoin evolved. Okay, so this is a website, history of Bitcoin. Uh, so Jyoti ma'am, Preeti ma'am, Sonal ma'am, can you just acknowledge with yes or no whether you could land on this page? Can I get one yes or no in the chat box whether you have landed on this page, that history of Bitcoin? Can I get any one yes or no? Okay, Jyoti ma'am, not it. You just try. It is just simple. You copy paste this address, history of Bitcoin. Okay, this will give you the complete history of the Bitcoin. So now you can drag it through the timeline. So you started in 2007, like that you can drag this and you can identify it. Okay, Else you can navigate the next and the previous button here. So it says that in 2007 the legend who's the legend for this Bitcoin is the Satoshi Nakamoto. Actually, um, this is an anonymous name. Okay, we might not, and we does not know who is the actual founder or the creator of this Bitcoin. Okay, but he created some white papers in the anonymous name. Okay, Satoshi Nakamoto in August 15 2008. So you can observe some historical point associated with them by going through this it's called next and the previous buttons. Okay, you can identify few interesting history of this Bitcoin. Okay, so now in August 15 2008 an interesting patent application has formed. Then another milestone in this is 2008 Bitcoin org is registered. Okay. Yes, thank you, Sonali ma'am. Thank you for your kind response. Happy to see that you also landed on this particular history of Bitcoin website. Okay, you can share this particular website to your students community as well, or to the beginners whoever love to learn with Bitcoin. They could understand the history of Bitcoin. Okay, so now you can go through like this. So white paper is published in 2008, like that. Source 4G, the Bitcoin project was evolved in November 2008. Else, if you want to drag the line, you can drag the line and you can see this what is happening. Okay, so we can have this a slider here. Okay, in the slider, if you want to particularly want to know what is actually happening this particular year. Okay, so in 2010 there was an OpenGL is created for this blockchain. Like this you can create so a blockchain app, a Bitcoin app for iPad is released in 2011. Like that you can spend your time, or you can ask your learners. You can give a assignment to your students as well. Okay, so let them explore in. You can give as a um, it's called teamwork. So let them understand when this has been created. Like just give some time period 2002 to 2008 to 2010. You can give one team to understand about it, and you can discuss about. You can ask the students to discuss about what is the learning in your class as well. Okay, like this I used to give some active based learning for my students as well. So students also will find interesting in going through this animated history of blockchain. Okay, so like that you can create you can understand what was the background happens in towards this Bitcoin of the blockchain. Okay, so I'll just go through the slide now. That is history of blockchain has got over. So as per the history, it says from 2008, and there was a drastic development till 2016, and after that, the development is very huge. So that it comes to the market, and to many of us will understood the need and the usage of this blockchain. Okay, so we'll see how this blockchain works now. Okay, so working of the blockchain is being illustrated here. It, as I said, it is distributed. Okay, it is distributed. The important point with the blockchain is distributed. Though it is distributed, we should have some synchronization. Okay, so some understanding should happen across the blocks. So synchronization is again an important point to be remembered with respect to blockchain. And next, as I said, it is peer-to-peer communication. Okay, so if I talk, I'll expect someone to reply me to me. Okay, that is what is expected in the blockchain. Okay, so it ensures a peer-to-peer communication, and always it gives an encryption transmission as well. Okay, the other important point to be observed in the blockchains are it focuses on decentralized, and traceability is very very important. That is what it creates a huge impact in the banking sectors nowadays. So it is transparent, that is, it is not controlled by a single party. No third party involvement happens inside the blockchain. And we have a consensus. So as ma'am said, Priya ma'am has said about consensus algorithm. Yes, we have a consensus happens here. Okay, so instead of having a single party, one party decision, we'll make a consensus among the group. We'll get the decisions. Okay, the decision among the group will be it's called accepted, and it will be validated, and that will be it's called incorporated. Okay, and it creates an immutable ledger. It as it is immutable. Okay, it cannot be irreversible as well. Okay, we cannot erase it back. That is an important point. Okay, there is no eraser for this. Okay, so that's what it is. Immutable ledger. Blockchain is an immutable ledger, and it is irreversible records. Once a block is being added, okay, removing it permanently is not possible because it creates a permanent record with respect to the chain. Okay, so every block will have the header and the blocks into it and creates a chain. We'll call them as a blockchain. Okay, so we use a word called distributor. Let us see what is all this distributed ledger. Uh, am I clear till this? Can I get one yes or no in the chat box? I'll happy to see the answer at least for this Y or N. Even I'll just give you the easiest way. Am I clear till this Y or N in the chat box? My learners of around 41 members are there. Thank you, Jyoti ma'am. Thank you so much for your immediate response. So I think I'm clear, so I can take the same speed. Thank you, PT ma'am. Thank you. Fine. I'll just go with the same flow then. Okay. So this is the distributed ledger. Okay. I just brought a differentiation between a centralized ledger and a distributed ledger. Okay. You can see in the centralized ledger, the bank, the single owner or the single entity which is going to control everyone. Okay. They are going to control all the client A, B, C, D. Everyone will be controlled by the centralized location. Okay. If this particular blank or if this particular financial sector is down, then there is a huge loss for all the client which is getting associated with the bank. Okay, now that scenario is being it's being resolved using the distributed ledger. Okay, in the distributed ledger, every node will act like a owner. Okay, so we have a node A, node B, node C, node D, node E. So whatever data is being dispatched or the details which is known to node A, it will have a replica for node B also. Node B will not say that I does not know what is happening. Okay, that will not happen in the distributed ledger. Okay, so there is one ledger. All the nodes will have same level of access. Okay, so if node B like to access through node E, yes, it could access it. Okay, that is what it said. All nodes will have the same level of access to that particular ledger. Okay, whereas in this particular domain, only the bank is the centralized person is allowed to access all the ledgers, not by the other client A, client B, client C. Okay, so this is one of the way. Distributed ledger is one way which ensures this achieving consensus algorithm. Okay, because it is giving a priority or it is giving rights to everyone to access it, so everyone can put forth their the thought or their commencement into the system. So this will give you the difference between a centralized and the distributed ledger. So this is an example for a centralized one. Okay, so this is inefficient, inexpensive, and it is vulnerable. Okay, so here you see there is a different color of ledger. This particular ledger is green color, blue color, and purple color, red color. Okay, all these ledgers are different color, signifies they have a different priorities or different information, and there is no data consistency happens in this the particular ledger. Okay, so this drawback is being overcome by the a common ledger, a distributed ledger. Okay, so previous example is an example for centralized one, and this is an example for the distributed one. Okay, so we have a ledger which is it's called a similar ledger of same color. You could see every entity who's participating in this particular network will have same type of information. Okay, so the data will be replicated, it will be shared. Okay, and we have this permissioned sector. Okay, so it ensures consensus. Yes, blockchain, it ensures consensus, it ensures provenance, and immutability is availability there, and it ensures the final acceptance as well. Okay, so this just gives a insight between what is actually happening in the centralized ledger and the distributed ledger. Yes, we have seen distributed. Let us see what actually is going to happen in this particular distributed ledger. Okay, so what is the first and foremost point This is the first and foremost point in the distributed ledger. What is it? We have to initiate the transaction. The user, whoever wants to create a blockchain, he needs to initiate the transaction. Okay, using what? Using their digital signature. Okay, so first point is initiating the transaction by the user using our digital signature. Okay, that was the first and the foremost step. In the second step, what is actually happening? The user, this user, okay, it is they are going to broadcast the transaction to all the nodes. Okay, they will transact like this. Okay, they will broadcast this particular transaction which is being just created in step one. They will broadcast to all the nodes. Okay, now one or more, this is the third important step where the consensus algorithm will come into the picture. Okay, one or more, it will validate every transaction. Okay, so this is playing a vital role in the blockchain technology. Whatever data is being broadcasted by the user, it has to be validated. Okay, then the validated data is going to be loaded. It is a blocks. Okay, the nodes aggregate the validated transaction into blocks. Now the block is ready. Okay, once its validation is over, it create a block. It creates an entity. Okay, now that node broadcasts the block to each other. Okay, the created blocks. Now, here only blocks is being created. In the fourth step only block will be created, and now this created block will be broadcasted. You see the difference. In step 2, the transaction is broadcasted. Okay, the transaction is the data what we created with the digital signature is broadcasted, whereas in step 5 the block is going to be broadcasted here. Okay, then if you want to create some validity or using the consensus algorithm, you can use all the algorithms here. Okay, then it will be chained. Okay, if you want to make the block to be chained, again a validation happens here using the consensus algorithm. Okay, then it will be chained to the prior block. Okay, this is actually happening in the distributed ledger. Okay, so we have seen in the first block, so the user will create a signature, digital signature. We'll call them as a this transaction. Okay, then in step 2, this is step 1. In step 2, what we have done, we broadcasted this transactions to every node. Okay, that is what we have done it in the step 2. And in step 3, we validated it. Okay, we validated this transaction. After validation of transactions, we will create a block here. In the step 4 only, we are creating a block. Okay, now in the step 5, this block will be broadcasted. Block will be broadcasted. Okay, then the broadcasted block will be validated using the consensus algorithm, and in the step 7, it will be chained. The blocks will be chained. Am I clear till this? Can I get any yes or no? Priti ma'am and Jyoti ma'am, I'll happy to see your answer. Or just type Y or N. If I'm clear, just type Y or N. Yes, thank you, Jyoti ma'am. Thank you. Fine. So this is the working conditions of the distributed ledger works. Then we will see an important parameter called cryptography. Okay, so we have this public key cryptography. You might have learned it or heard about during our learning in the computer network. Okay, the allies and the Bob will transact some information, and then a data key will be encrypted. The encrypted key can be a public key or it can be a private key. Similar thing, we are going to have this cryptography, public key cryptography here. Okay, so we are going to have a pair of key in this cryptography. One will call them as a public key, another will call them as a private key. So we have a public key here and we are going to have a private key. As the name indicates, public key will be, it may be disseminated widely, whereas private key will be owned only by the user. Okay, and the two important function which is getting associated with this cryptography is authentication and encryption. Obviously, your data has to be authenticated and it will be in a protected way. It has to be encrypted. Okay, in order to ensure privacy. Okay, you are going to make an encryption here. Okay, so many signature algorithms are available. The most widely used algorithm is ECDSA, Eclipse Curve Digital Signature Algorithm. Okay, Eclipse Curves Digital. Now we'll see how this Alice and Bob is going to transmit the data. Okay, so if it is a public key is being created, okay, the copy of the public key will be sent to the everyone. Okay, it is going to be distributed. Okay, distributed, or it is going to be broadcasted. Okay, whereas the private key, which is being created by allies, is going to be owned by a signing algorithm. Okay, then that signing algorithm will create a signature with respect to that particular user. Okay, then it will be verified in this node of blockchain. Signature verification algorithm will help us to validate whether this particular transaction being created is a valid one or not. Okay, once the transaction is authenticated, then a block will be created. Okay, this is the actual process happening in terms of the cryptography. Okay, next we are going to learn a new important terminology called hashing function. Okay, so whenever you heard about blockchain, this hash key will come in associated with it. Okay, hands to on, we have this association with this hashing. So this hash function is any function. Okay, so hash function is any function. So before I go to hash function, can I get in the chat box how many of you know about hash function? Can I get an yes or no? Based on that, I will dig the concept. If it is no problem, I will dig it. If it is yes, I will just tell you what is. I will just recap it and I'll go to the next topic. Can I get S or no, Y or N about hash function? So what does the silence signifies? Okay, I'll take the silence as no then. So hash function is any function. We are going to create a function. Okay, remember hash is a function which is going to map a digital data of arbitrary size. The size of the data can be of any size. Okay, it is going to map a digital data of arbitrary size to digital data of fixed size. Very, very important. Okay, so irrespective of the size of the input data, it is going to give a fixed size of your data. That is what hashing is going to perform. So hash function, I'll repeat, hash is a function. It is a function. Okay, what is it going to do? It is going to map the digital data arbitrary size. Okay, it can be of 200. It can be the input data of size 200, or if the input data can be of 500. Okay, irrespective of the size of the input, i'm going to create a fixed size data. Okay, that fixed size data can be a 256 bits based on the capacity of the system, or it can be of 64 hexadecimal character. Like that we will convert it. Okay, this is called a hashing function. So I'll just repeat, hash is a function which is going to give, it's going to map, okay, digital data of arbitrary size to digital data of fixed size. Okay, so what are the parameters which gets associated with this hash function? We have a hash value, we have a hash code, hash sum, and hashes. Okay, so these are the values which gets associated with this particular hashing function. Okay, and the most promising algorithm used in this hashing is SHA 256. SHA, the expansion is secure hash algorithm. Okay, 256 indicates a bit size. Okay, so the output will be of 256 bits of data, or it can be of 64 hexadecimal character. This is all about the hash function. So as I said, we are going to create data of any size if same length. Okay, that is our first and foremost work of your hashing function. Okay, now you see hello data. Hello data, I've given it. It will create a hash function of same size. Okay, here allow world with exclamatory. So here the size will be 1 2 3 4 5 6 7 8 9 10 11. Okay, here the character size is 11, and here the character size is 12 because one exclamatory mark is added. Irrespective of the size, you see it's going to create of 64 hexadecimal value of same bit. Okay, that is what is a hashing function. So irrespective of the arbitrary data size of the input, it is going to give a fixed value of the exa values as an output. Okay, the same out for any same input. Okay, if I type hello world for n times or 100 times, only the same output will be produced. Same input always produces the same output. The hashes are one way. Okay, you cannot be reversed it. Okay, that is what is irreversible. Okay, so hashes are one way. How this hash key will be returned as a function. Okay, the function is SHA-256. SHA expansion secured hash algorithm. Okay, 256 cell bit length. So what are the important parameters that is being passed to the hash 256 is the block number. So we have a block number here, timestamp here, nouns, data, previous block, okay, hash, block hash, everything. Well, all together collectively will give you the hash value. Okay, that is what is going to be calculated. We'll see what is this nouns and what is how this previous block is getting associated now. Okay, so how many of you heard about this simulation of Anders Brown work? Thank you, Sonali ma'am, for your response. I just observing it. Now you can see this Anders Brown work simulation of the website. Okay, you can copy paste it in your. You can copy paste it here. Okay, you could see this is a hash. Okay, we said we are creating a hash function, right? So this is the hash. Okay, so whatever data I type it, welcome. So I'm typing welcome. You see, a hash key is changed. Okay, previously the hash key was for blank. It is created. I'm creating a hash key for welcome now. So same size hash key is being created. A 64-bit hexadecimal 64-bit value is being created for welcome. Even if I type, or if you add more, it's called characters to it. Welcome you all for unblocking. You could see whatever values I type it immediately, the hash values is getting changed, but the size is common. Okay, welcome you all for the unblocking the blockchain session. So I can give one second. What happened?
I will talk about the
Statistics. Come later. Sorry. So we have this blockchains. So whatever irrespective of the size of the input data, hash will create a fixed size of 64 hexadecimal value for the corresponding information. Okay, this is the observation about the hash function. You might have heard about hashing in the blockchain. This will give you the understanding. Okay, so whatever value I type it here, okay, whatever value I type it here, you can see the size of the data will be of 64 bit of hexadecimal value. Okay, even if I delete it, you see the same thing, but will be created. Okay, so this is about the blocks hash. That is all about the hash, and now we'll see about the block. Okay, so this particular simulation website will help us to understand the block number, the nouns value, the data, and the hash. Okay, I'll just go back to the slide and I'll come back again. Okay, so we just learned what is the demo for how the hash is being created. Okay, so next we'll see what is this block. Okay, so every block, as we said, SHA, we've seen that SHA will have this the block number, the timestamp, the nouns, block number, timestamp, the nouns, the data, all these things is being incorporated here. Okay, so now we are going to see how these values is being going to be generated here. Okay, so I have a block here. This is my block number, and this is a nouns value. What do you want? Come later. Evening by 4 o'clock. Sorry. So the nouns value, we have it here, and we have the data here. Okay, so for all this thing, the hash will be hash key as function will create a hash value for it. So now we'll see the demo for it. So this is my number. Okay, nouns number, it's not being created as okay. So now you can create a data here. Okay, so if I take my name, Maheshwari Raja. Okay, so it creates a hash value for this particular data. Okay, so if I like to, now you see the color is light pink color, okay, pink shade. So if I mine it, it will convert it to green color. So green color indicates that yes, your data is being mined, it's validated. So that block will be created. Okay. So now it will create, the color will change to green. That ensures that the block
Hello.
is being created for
Hello.
this particular
Hello.
data.
Hello.
Okay, so that is all about the block. So now block is over. Next, we have to see the chain. Okay, before I go into the chain, it's my duty to explore what is all about this Genesis block in the blockchain. You might have heard about this word Genesis block. Okay, so I'll just recollect it. Genesis block is the first block of a blockchain. This is an ancestor block. Okay, Genesis block is the first block of any particular blockchain. If you're creating a new block, then we'll call them as a Genesis block. The first ever block being created is in the blockchain is a Genesis block. Okay, so this particular blockchain block is being mined in 2009 by Satoshi Nakoshi's team. Okay, so this Genesis block, the important parameter which observed in the Genesis block is it will be of block zero. Okay, it will not have any previous block transaction. The history will not be there because it is the first block being created. Okay, so with that particular thing, we've come to know whether this is a particular Genesis block or the it is a normal chained block. Okay, so Genesis block will have the previous transaction block informations will be 000. Okay, for first block, the information, the hash key will all be the previous hash key will be your 000. Okay, for all other blocks it will be n minus 1. Okay, so n minus 1 location will be tagged, it will be linked with this transaction. Okay, so this is all about the Genesis block. So now I just go through this actually this is a hash. We learned about the first tab in this particular simulation website is a hash. We learned about hash, and the second block is second tab is block. We learned about the block as well. Now it's time to create a blockchain. This is a single block, and we'll have a more number of blocks. So you see this is a block, many blocks is going to be chained now. Okay, now you see the previous the hash value of the first block will be equivalent to the previous block value of the second block. Okay, so you see it ends with CF. Yes, it also ends with CF. Okay, again the hash value of this value C19 will be the hash value for the next one. Okay, so you could see C19 happens. Like here, you can create a chains of blocks in order to create a blockchain. So this particular demonstration will help you to understand. Previous things helps to will make you to realize or visualize about the blocks. So this will help us to understand the interconnection between the blocks. This blockchain is being created. So you can create some data. Now once the data is being created, you see all the things will become a pink color. It indicates you created a data, but it is not validated. Okay, so you have to validate using by the button called mine button. Once you click this mine button, once your data is being validated and verified, it will be added to the chain by using the color called green color. Okay, now this particular block is authenticated, validated, and it is being mined. Okay, now if you want to send the data of some 5000K, okay, so you have to mine it again this block. So after see, you can see the change color in the block. It indicates whether the particular blocks is mined or it is unmined. Okay, so whether it is a validator or invalidator. Okay, so like this you can keep on adding to the blocks in the blockchain. Am I clear to this? Can I get at least one or yes or no in the chat box? One yes or one no? Jyoti ma'am and Sonali ma'am. Sonal ma'am, sorry, Sonal ma'am. Okay, so this is all about the distributed blockchain. In the distributed blockchain, I'll show you what is actually happening in the distributed blockchain. You can see in the distributed blockchain, a two network is being created. Okay, so peer A, and you can come down to understand peer B. So in the previous tab, it is just a blockchain in the same network. Okay, only one network is being considered for this demo. Whereas in the distributed one, you could observe there are two networks being created. One network is called as peer A network, and another network is called as a peer B network, peer C. Like that, you can create a distributed platform in order to mine it. Okay, so even you can check, you can give the information, and you can keep checking this particular thing. Now you see it all becomes, this becomes green. Okay, so it is not bind now. Again, this is not mined. Okay, so if you give one more data here, we have to mine it in this particular network. Okay, network to network simulation happens in this particular distributed blockchain. Okay, even tokens, you can create tokens. Okay, so there was a tab called the token tab here. Next tab is token tab that help us to understand how much data. Okay, so far I talked about in terms of letters, characters. Okay, welcome, all these are characters, but blockchain is all about a currency, right? So every currency will have a value to it. Okay, so here you can create a transaction amount, how much transaction is going, you are going to transmit. Okay, so I can transmit 125 transaction from whom to whom. You can select from whom to whom. Okay, then you can mine it. So once you mine it, okay, this particular values are being authenticated. I'm transmitting 125 dollars from Darcy to Bingley. Okay, like this you can create transactions in terms of the amount, and it says to whom you are going to give it. Okay, this is all about the token creations, the transaction creations, I can say transaction creations in the blockchain. Okay, even you can create a coin base. Okay, coin bases you can create it. Even that is the rate at which the data is being transmitted, that you can create it using a coins based transaction. That's all. So this simulation will give you the understanding about what is hash, what is, how blocks is being created, how the hash function works, everything, and the peer to peer, peer A, how peer B, network to network establishment, everything you can visualize it using that particular simulation. Next, adding blocks to the blockchain. That's very, very important. Who is going to help us in adding the blocks to the blockchain? Obviously, the miners. Okay, all the miners in the Bitcoin network will compete with each other. Okay, all the participants as a miner, they will compete each other in order to find the valid block. Okay, it is like a treasure hunt. Okay, treasure hunt will be open to all the participants. They have to run and they have to take the token, right? They have to identify the clue. Okay, same thing happens here in the blockchain as well. Okay, so whoever miners or whoever participant or the user who is going to get the hunt, they will be awarded here. Okay, so with each other to find the valid block that will be added to the blockchain and will get the reward from the network. Okay, whoever is whichever miner is getting award, they will be rewarded by the network. Okay, the first miner, okay, the first miner who submit the valid block will be added to the just called, they will be rewarded, and that will be added to the chain. Okay, that is the second important point to be observed in the blockchain, how the blocks is being added to the blockchain. Then what happens if two miners submit the blocks at the same time? Okay, in the same time stamp, 10 o'clock 50 seconds. Imagine two blocks, two miners are submitting the same block. Okay, during that time, what will happen? That is what is called 51% attack will come. Okay, so whoever block is being extended, okay, then that will be added. I will address this in the next slide. Okay, then very important point, validate your block is your finding the nouns value. Okay, nouns value is a one-time value. Okay, that help us to identify whether this validation is correct or not. Okay, that is a probability of identifying the values to the network. Okay, so this is the these are the ways you can add your blocks to your blockchain. Okay, so as I said, what happens with the same at the same time when two blocks is being added by the two different miners? Okay, so it will not get panic. It will allow both the miners to add into the chain. Okay, then who will be selected for the next level? That will be decided by the other next block to be added. Okay, so imagine I have block A and block B here. The two blocks is mined at the same time. Okay, now if fifth block is mined and added to block of 4A, then this particular chain will be authenticated. Okay, and this will be discarded. Block 4B will be discarded because he does not have anyone to what's called support him. Okay, so since block 5 supported for fourth block of A component, he will be allowed in the chain and he will continue his journey in the blockchain. Okay, this is what happens whenever there is a conflict happens with respect to the two blocks or n number of blocks in the minus in the blockchain. Very important point, we have to understand this Merkle tree. Okay, Merkle tree is a data structure. As like you might have heard about a stack, a queue, all this data structures. We have a Merkle tree as a data structure in the this one blockchain. Okay, so this Merkle tree is a data structure. It is going to what is going to contain? It is going to contain the hashes of different blocks. Okay, it is like an addresses of all the blocks. So hashes of all the blocks will be held in a tree called a hash Merkle tree. Merkle tree is going to contain all the hash values of this particular network. Okay, correspondingly the transactions will be here attached with the last the root level will contain the transaction. Okay, so this Merkle tree is a binary tree. As it's a binary tree, you have to maintain a even number of leaf nodes. Okay, there should be a balanced network. Binary tree is a balanced network, right? The left hand side tree should be equivalent with the right hand side tree. Okay, so this will be ensured after adding every node into the tree. This always being ensured that it ensures the binary tree transaction happens. Okay, so if there is an odd number of transaction happens, then the last hash will be duplicated again in order to balance the structure. Okay, so every time we cannot expect even number of leaf node will be generated, right? Yes, even if it is an odd number of transaction happens, it will not it's called destroy the structure. Immediately it will duplicate the last hash tree in order to uh, balance the hash tree of the binary structure. Okay, in the Merkle tree. So this Merkle tree, what does it stores? It stores the block header. Okay, it is stored in the block header. This is what your Merkle tree looks like. You have all transactions here. Okay, so what are the components? It will have it. The block header will hold this Merkle tree root hashes. Okay, all the hashes will be listed out and the corresponding transactions will be associated with all the Merkle tree. So for every block header, it will have a Merkle tree, and the Merkle tree will have this all the hash tree with the corresponding a transaction associated with it. So this is a sample block. So the block, every block of the blockchain will have the version number, the previous hash block values, Merkle root values. Okay, this is the hash values. Okay, timestamp, the nonce value, and the transaction amount. All this thing will be held up in this particular block. Okay. So we have this consensus algorithm. I think yesterday's session you might have covered this consensus algorithm. Okay, there are various consensus algorithms that are available in order to validate the block being created. Okay, so proof of work, the various agreement works we have. It is a proof of work POW. It's a commonly used consensus algorithm. We'll call them as POW. POW is proof of work, and POS proof of state, proof of capacity, proof of burn, proof of importance, proof of activity, and elapsed time. There are many consensus algorithms available. Okay. So now we'll see how this minus, okay, how this minus helps us to store this particular blocks into the blockchain. That is actually we whatever we have seen it, it's getting it's called summarized here. So the minus will help us to add the blocks to the blockchain. You keep it in the mind that who is going to help in adding the block. The minus only is going to help us in adding the blocks into the blockchain network. Okay, so he has to validate it, and he has to verify everything. That is what the work of the minus. Now it's time for us to understand that important term called nouns. Okay, number once used once. As I said, it's a one time. It's like OTP. Okay, so it's like a OTP, one time used password. Okay, so we have this nouns is also a number used once. Okay, so in order to meet the difficulties, we will inject this number. Okay, it is like you can remember like a the key, the number lock will be there, right? In the number lock, if it is a 3-bit number lock or a 10-bit number lock, based on the bit, the number will get varied, right? So if you give the incorrect value, the lock will not open. But if you give the correct value, digital value, then the lock will be automatically gets opened. Okay, similarly, here the nouns value, if you give the correct nouns value, then it will give the authentication. If the nouns value is wrong, then it will consider as a wrong assumption or a wrong answer. It will not open the block. Okay, it will not unblock the block. Okay, this is the nouns number. So instead of uh, having a huge number, it will have one single nouns number. So the minus job is to identify the value of the nouns. Okay, if the miner find out this nouns value, then he will be rewarded, and his block will be added to the network. That is the work of the minus. The minus job is to identify, he has to guess the value of the nouns. Okay, and it will help us to add into the network. Okay, and this is a proof of work. So the process of in the proof of work, the process of finding the nouns will called as a proof of work. Okay, so the minus will it's called it will he will identify the nouns value, then he will distribute it, he will broadcast to what. Okay, then the particular nouns value will be checked in the database. So if it is correct, then it will be verified and validated, and that will be added to the network, else it will be discarded. Okay, that is a consensus algorithm here. 51 percentage attack. So who will be a validated user, the who will be the validated link, who is going to who's going to rule the market of blockchain. We'll call them as a 51 percentage attack. Okay, so whenever I have 100 percentage, if both are 50-50, both are 50-50, equal rights has to be given. So no one is allowed to rule it. Okay, so whoever is having extra 1 percentage, okay, then that particular network will be allowed to rule the network. The others has to work like a slave. Okay, so whoever having extra plus 1, okay, that is like a majority. Okay, whoever having the majority of the blocks, okay, they will be ruling the network. Okay, so they are very it's called crucial, and they have to be taken care, much care has to be taken for this particular attack, because they have the probability of removing changing some transactions, all these things they can do it. Okay, so they can try to reverse the transaction. Okay, so that is a major drawback of this 51 attack. So this particular 51 percentage block will help. They will try to rule the community. Okay, they could prevent transactions from gaining from any confirmations. Even they can prevent the transaction. They prevent people from sending bitcoins between addresses. Okay, like that they will try to rule the complete network. Okay, they will generate majority of the blocks, and they prevent other miners. Okay, so all these things they will do it in the 51 percentage attack. 51 percentage is nothing but whoever's having majority, they will try to rule the network. Okay, and we have this private and the publicly blockchain. We all know there will be a limitations with both the public key and the private key. One second. Sorry. So we have this a public blockchain. So it is open to peer to peer. Okay, anyone can participate and anyone can leave it without notification. But these are all will create some it is called insecure to our system. Okay, so it can be anonymous, untrusted participant can come into it. So it also shows the large scale distributed ledger. Okay, in order to overcome this, we have a private blockchain network as well. We all just opposite to the public network, it is closed and permissioned. We have a trusted participants into it, we regulate some control. Okay, we always go toward small to the medium scale distributed ledger for the private blockchain. Okay, this is the understanding of how where are the layers. Okay, and what are the terminologies which are getting associated with the layers. Okay, so in the distribution, first this is the transaction being created by the user. Okay, and the contract is being created by the user. This is called the transaction layer. So this is the first most layer where I told you in the beginning itself, signing digital signature helps to create the transaction. Okay, this is a transaction layer, and then the transaction has to be validated. Okay, and during validation, the blocks will be created. Okay, so validation and distribution of transaction will happen here. Validation happens in the validation layer. Okay, then after this validation layer, this will be the block will be added to the network using this consensus algorithm. Okay, block generation layer using this consensus algorithm. Okay, then it will be distributed in the distribution layer. So we have few important layers apart from the network layers in the network. We have seen it. We have the block in the blockchain also. We have layers like transaction layer, validation, block generation, and the distribution layers. Okay, so we are start the next venture of our learning called contracts. Okay, smart contracts. We are going to start our learning with smart contracts now. So before I go with the learning of smart contracts, let us understand who is a participant, what is a transaction, and what is a contract. Okay, so who are the participants? Participants can be any member. Any member of the business network is a participant. He can be a customer, supplier, government, or regulator. Okay, any member can act as any participant of the network. Okay, usually they reside in an organization. Okay, say whoever I say it is a bank manager, he might be belong to a bank sector. Okay, COE will belong to some company like that. They will belong to any of the organization, and they have a specific values and roles to be carried out. Okay, they are the participants. Next is the transaction. Transactions is the asset, that the quantum of data, the quantum of the money or the asset to be transferred between two parties. Okay, if for example John wants to give the car to Anthony, then the transaction of car happens here. Okay, the car with respect to money. Okay, one will get the car and other will get the money. Okay, so the asset transfer will happen in the transaction. And what is contract here? If you're going to state some condition, if condition, if true, okay, then that is called a contract. Okay, conditions for transactions to occur. Okay, so if for example if Anthony is paying the car to the sorry Anthony is paying some money to get the car. Okay, if the car is not working, okay, then there is $100 question mark to revert the process. Okay, so this thing, so if the car does not start, then fund do not pass to John. So that type of authentication will happen in terms of the blockchain. Okay, as decided by the third party, we will write a protocol for it. Okay, so if the car does not start, don't initiate the amount to be transmitted or committed. Okay, like that you can create some conditions for it, that is called a contract. Okay, so before I go with the contract, for smart contract implementation and learning, it's time for me to give your break to your brain. Okay, so this is a general common question, a general knowledge test. Can you just tell me the world's biggest bank with no cash, and the world's largest taxi company owns no vehicle? Item number 3. Item number 3 is the world's most popular media owner creates no content, and the world's most valuable retailer which who has no inventory, and the world's largest accommodator owns no retail estate. I could see some answers in the. I would like to see some answers in the chat box. You can type number and you can post the answer. The world's largest bank with no cash, actual cash, and the company, taxi company who owns no vehicle. I think you can get a guess for the media owner who creates no content, but he is a popular media owner. Any guess, participants? Any guess for this answer questions? I'll just give you a few minutes. The largest bank with no actual cash. Any guess? No guess. I'm not going to give mark, right? Just give some try. Whatever terms comes into your mind, you just try to put it here. The world's most popular media owner creates no content. I think that you can guess. Largest accommodation provider who owns no real estate. Okay, I'll just through the answer now. So the first one is Bitcoin. So Bitcoin is the world's largest bank with no actual cash, and taxi is the Uber. I guess you may tell this Uber or Ola at least. So Uber is the answer. The world's largest taxi company who owns no vehicles, and media provider is Facebook. Okay, Facebook is a popular media provider, and the inventory retailer is Alibaba, and the accommodation provider is Airbnb. So, okay, fine. I'll just move to the learning now. So we have a smart contract. Okay, so smart contract will have as I said, contract, we are going to create some conditions. Okay, so that condition we are going to write in terms of code. We are going to write a code for this in order to create a contract. Okay, so it will be in the form of code stored in the blockchain. It will be stored in the blockchain and executes under given condition. Okay, so whenever we need to execute that contract, it will get executed. Okay, so every block will have a contracts like this. You have a contracts here. Okay, so it will have a code and it will be stored in the blockchain. Okay, so the owner who is going to create the contract, the owner will create the contract. Okay, so if the car is not if car is not starting, okay, we have to block the payment, right? So who is going to create that contract? The owner will create the contract. Okay, so owner will create the condition. Okay, then the contract replicates among all the nodes. Okay, so then after creating the contract, the owner will ask to dispatch this contract to all the nodes in the network, so that data inconsistency will not happen. It ensures data consistency. Whatever data known to one block or one network will be known to the other network of the system as well. Okay, that is what the important things to be observed in the contract. Then if the tenant wants to deposits to the contract, okay, so this is the owner here. Okay, owner will create some contract, will dispatch to all the thing. Then if the tenant want to deposit the amount, okay, now the contract state changes to all the nodes. Okay, so now the tenant will deposit it. So previously the owner has created the contract. Now the tenant will deposit the thing. Okay, now all the nodes will change the it's called deposit. The value of deposit is being updated in all the ledger. Okay, it says that if the owner checks this particular network, he will come to know, yes, the tenant has deposited the amount or not. If not in the A network, if you like, he tries to reach the C network, even in there the data is consistently available. Okay, so then this is to check if the owner like to check the balance in any network, he can get through what So this is what a smart contracts happen. So the contract state is fetched from one node and that will be added to the owner. Okay, fine. So there is a difference between a traditional contract and a smart contract. In traditional contract, we need a minimum of 1 to 3 days to execute it, whereas in smart contract, if you know the conditions, you can create the contracts in minutes. And you need an annual remittance happens in the manual remittance happens in the traditional contract. Here, automatic remittance will happen in the smart contract. Yes, we need an escrow necessary. Okay, the lawyer's escrow is necessary for this. Here escrow may not be necessary. Okay, based on the it's called quantum of transaction happens, you can decide whether you need this escrows or not. Okay, and this is expensive because you have to create document everything. Okay, here it is you can create at the low cost. Okay, then here we have a physical presence. Wet signature is required. Okay, a witness is required in this physical traditional contract. Here, digital signature is more than enough. Okay, virtual presence is more than enough for this smart contract. Yes, here as escrow is necessary, lawyers is also necessary here. Lawyers may not be necessary for this smart contracts. Based on basic holding this basic idea about the smart contracts, let's start our learning how to create the smart contract in this Ethereum Solidity. Okay, so Ethereum, you might have heard this word Ethereum widely. Okay, so this particular Ethereum, it's enormously powerful and shared global infrastructure for whom to build a decentralized application. Okay, so like a programming language like Solidity, you can create a smart contract using Ethereum, and you can it's called widely used across it. What is Solidity? You might have heard this term Solidity, but let us see what is the Solidity. Actually, it is a programming language. Okay, as like your C and C++, Java, Python, JavaScript. Okay, it is a programming language, high-level programming language. Solidity is a high-level programming language. Okay, so it is focused on designing and implementing smart contract. So this flavor of combination of C++, JavaScript and Python, when you combine all the C++, Java and Python, JavaScript and Python, we could get this Solidity language. Yes, since it is Java and C++, it is object oriented. Okay, Solidity is object oriented, and it is also contract oriented. Since we are creating a contract, it should be a contract oriented as well. It's a high level language. It has an influence of C++, Python and JavaScript. Okay, it runs on a target machine called EVM. Yes, it needs a virtual machine to run. We'll call them as EVM, Ethereum virtual machine. So we have an Ethereum virtual machines to run this Solidity. Okay, it also supports various data types like boolean, integer, address, string. These are the various data types it supports. As like a normal programming language like C++, Java, it supports a boolean, integer, address. So here we have a special terminology called address, because data is being sent across the nodes, right? So address has become one of the important parameter or the data type for the in the Solidity. Okay, so you have a state variables, local variables, and global variables. State variables means the value will be stored permanently in the contract. If you like to store the data permanently in the contract, you have to define that as a state variable. If you like to use a validity period, okay, within the function. Okay, if it is it should be accessible inside the function. You can make it as a global variable. Okay, whereas global variables or special variables, it could be used across the blockchain. Okay, across the blockchain, if you like to retain the data, we'll make them as a global variable. Okay, so this diagram will help us to understand what is the Solidity, how it compiles, and what is the need for Ethereum EVM. Okay, so Solidity again, it's a program, it's a code. Okay, so the now that after compilation, it creates a bytecodes. As like any other programming language, after compilation, Solidity is also going to create a bytecode. So the name for the bytecode is Ethereum bytecode. Okay, and to execute this Ethereum bytecode, I need a virtual machine called Ethereum virtual machine. Okay, as like we have a Java virtual machine, we have this to run this Ethereum bytecodes. We need this Ethereum virtual machine. Okay, so these are the steps to helps to support for the blockchain. We have a smart contract, developing a smart contract. First, we need to develop a smart contract. Then we need to compile the contract. then we need to deploy the contract, then we need to interact with it. As like as times goes on, if you want to add more function, you can add more functions to the uh, smart contract. Okay, deploying, compiling, sorry, develop the contract, compile the contract, deploy it, interact it, and adding more functions to the contract. Okay, so I'll just post this link in the chat box. Whoever wants to who wants to explore this Ethereum smart contract, you can go through this. Okay, you can go through this.
मॅडम प्रश्न कोणाला विचारायला सांगितले
You could see this. This is my Ethereum. So once you copy paste it, ethereum.org, you will land on this particular Remix Ethereum platform. Okay, so this is an open access website. You can access it wherever and whenever possible. Okay, so I'll just teach you how to code using this Ethereum. Okay, it's time for us to understand how to write a code using the smart contract. Sorry, using Solidity to create a contract. Okay, so I'll just go through now. Just we'll start coding here now. So as like the header files in your C programming, C++, okay, we have a pragma, a directive here. Okay, so we have a pragma solidity. The version number will be given. Okay, so based on the version, okay, the version you are using, we can use this pragma solidity. Okay, so once you open this smart contract new setup, okay, nothing will be there. It's an empty editor will be opened. Okay, there you have to give this first line as a solidity. Okay, so all solidity source code should start with this directive pragma. So pragma is a directive here. Okay, it's a non-executable conversion code here. Which declares the version of the solidity compiler. It's very important to understand this in order to know the version of the compiler, solidity compiler. Okay, so when I started creating this PPT, it was 0.5.0. Okay, now the new version might have started. Okay, then we have to write a program for it. Okay, so we have to write a program for it. We can write a contract. Okay, we have to create a contract. So if we have a keyword called contract. It's a reserved keyword. Okay. So you can create your contract by using a reserved word called contract, and you have to save the file with .sol. .sol, that indicates you are doing a solidity file. Okay, if you save it with .c, it's a .c file, right? Similarly, if it is .sol, we are going to create a solidity file. Okay, then every contract will have two important functions. One is getter function and another one is setter function. Okay, so that is what is given here. We have two important functions. One is getter function and another one is setter function.
Maheshwari, oh.
This is getter function and this is your setter function. Okay, getter function is to get the balance. Okay, for that you have a function, you have a reserved keyword called function. Get balance is your user defined variable. You can give any function name for it. Okay, and the balance, you are going to return the balance. Okay, this is a normal programming format. Okay, again deposit is a user defined variable where function is a predefined keyword. Okay, function deposit. So now the balance, whatever balance I'm adding it, I will add it with new deposit and it will return it. Okay, so these are the two functions we are creating here, and currently I'm keeping my balance as 31300. Okay, this is the current balance. I'm just keeping it. This is just a simple program which helps us to understand how to create a contract. Okay, so I'll just repeat. You have a pragma solidity that ensures this ensures the inclusion of the directive version number, and then you have a contract. We have to write a contract. So the contract name is financial contract. I have used it here. You can give any name for it. Okay, as like since it is similar to Java, the file name and the contract name should be same. Okay, that is very important point. You just keep it in the mind. Okay, the file name you're creating and the contract name you're creating should be same. Okay, so contract name will be the financial contract here. So I need to save the file name that's in a financial contract dot SOL. SOL is a solidity file. Okay, here I used we used two functions like getter function and the setter function. Getter function and setter functions to get the data, and setter function is to execute the data. Okay, you have to use a variable called the function in order to call the functions. Okay, so here unit is defined here. Balance variable is defined here with a basic value of 31300. The triple zero value is being used. Okay, that's all. So first one is we created the code. This is the first coding starting phases, developing a code. So code is being developed now. Okay, code is ready now. Now the code is to be compiled. Okay, so to compile the contract, there is a tab called start to compile. That was a tab to compile will be there. Okay, so you select the tab. So start to compile button. Then after compilation, we need to deploy it. Okay, so for that you have a button called deploy button to deploy this. And then after deploy, you can execute and see the output. Okay, once you deploy the code, okay, you could see you can get the what's called buttons. Okay, text box or the buttons, whatever code we have written it, we can get the output. Okay, so you can get the buttons, then you can interact with it using this. Now you see we used two functions like get and set, right? So deposit and get balance. Okay, if you like to deposit some number, you will type here and
मायनस
click
करायचं मग
deposit.
वेगळे लोड
Then
करायचं
if you
सोडतायत
click
बरे
get
दुसऱ्याला देत
balance,
नाही
you
लोड
will get the balance amount for it. Okay, I'll just show you the demonstration also. I have brought it. So in the deposit, see 31300, that's the basic unit we set here. So while writing the code, we just created the basic balance should be 313000. The same basic unit will be seen here in the execution as well. So unit size is
डोक्या
3130.
पण चालू
So whatever value you keep deposit here, it can be 100. If you type 100 and deposit, then if you click get balance, then the particular number will be added. Now you see deposit, I get 12 here. Okay, then after clicking deposit, after clicking get balance, the 12 will be added for this and the unit will be of this. Okay, this is the interact with the contract. Then if you want to add some other functions, you can add it based on the requirement of the function. Okay, so this is a smart contract functions. You can go to the you can go to this Ethereum website. Okay, so once you land on this Ethereum website, you could see it's a black color background will be seen. Okay, you can change the theme. Once you, if you're first user, you will have a theme of black color here. Okay, the left hand side down you have a settings button. The settings button, you click the settings button and then you can change the theme. So light color will be better. Even in the light color you have a various flavors. Okay, violet, unicorn, like that you can have some flavors, so you can select the flavors. Okay, so this is the Ethereum thing. Now I'll just show you how to create a code for this. The left hand side you could see a file explorer. You click the file explorer. Okay, you can see many components here. Okay, so that was the first one is create a new file. If you click this, a new file will be created. Even you can click this new file icon here to create the new file. Then you can click the open file to open your existing file. Okay, so now
मला इकडे दिसले नाही यायचे पण दोन्ही दिसला मला मी आता ते AI
I have created one thing. I'll just show that one. Okay. So now I created a contracts like storage.sol and owner.sol and few predefined solidity codes are available as well. Okay, so these are some predefined solidity codes available. Okay, so you can double click it so that you can see this storage solidity created. Okay, and the first line is pragma solidity. Okay, now you see the version is 8.2 to 8.9 it comes. Okay, then I forgot to tell you, before any pragma you have to write this command line. Okay, I'll tell you why this command line here. So that the command line is spdx license number under MIT, that was first developed by MIT people only. Okay, so they we have to give that what's called that tag has to be specified. Okay, the need for that tag is, yes, I have given here. The purpose of this SPDX licenses, it will enable to efficient and reliable identification. Okay, so the license authentication will happen here. Okay, so this is provided by the Linux Foundation. Okay, in the open source environment, whenever you use it, you have to use this hash double slash spdx license identifier by MIT. So we have to use this one. It's very important for us to write the contract. Okay, that is what it will be automatically inserted here. And as I said, pragma solidity, you have to write the version number for it. Then I told you contract, this is a place where we will start writing the contract. Okay, and this is the file name. Okay, storage, you see storage.sol is a file name. The contract name is also same. You just it's called correlate with the Java programming. The Java programming, we will have the same class name with your file name, right? So same thing. Excuse me. The contract name you have to say with the solidity name. Okay, and here integer number we have defined something. So here we are storing the number function. In order to write a function, you have to use a keyword called function. Okay, here in the previous code I had shown you two terms called deposit and balance. So here we are using a term called store and retrieve. Okay, it's user defined. In order to make you to understand, it's user defined, I use another terminology here, store and retrieve. Okay, in the store we are storing the values. Whatever value you are passing it in this particular text box, you are going to store it in the number. Okay, whereas in the retrieve you are going to just retrieve that number. Okay, so if you want to add it, then you can create number plus num equal to number. If you like to add that number, you can create this number as well. Okay, I'll just show you how to compile and execute. Now the code is ready. It's a predefined code only. It's like hello world program. Okay, now this is the first layout is file explorer. Okay, and the second is for search. You can skip it, and the third left hand side you can see solidity compiler. You click the solidity compiler. Okay, now you need to compile it. There was it's called tab like compile storage.sol. So you click this tab storage.sol. Okay, so solidity is compiled. If there is any error, it will throw an error here. Since it does not have any error, it's compiled. Then compile the run script. Okay, so now it is ready. Now you can go to this tab called deploy. So first we created using this, then using compile, we compiled the code. So during compilation, the Ethereum bytecode will be generated. Now this will be deployed. Okay, using deploy, you can see deploy here. You click deploy. Okay, so deploy is over. Once it is deployed, you could see deployed contracts in the left hand side corner. You click the storage. Now you could see store and retrieve. These are the two functions we use it there. Okay, so to store it, I'll just type some number, a unique number 9987. I'll type 9987. Okay, then you have to click store. Okay, now it will be stored. Then you click retrieve. You can see 9987. Can anyone acknowledge me in the chat box whether you could see this 9987 which is just being stored by me? Can I get anyone yes or no in the chat box? Yes or no in the chat box? Whether you could see this this unit being stored. So now I'll just change number as all ones. I'll store it. Then you could retrieve it. So all ones will be retrieved. Can I get at least one yes or no? Whether you could see the output in the remix Ethereum participants. So this is how you will store it and you will retrieve. Like that, you can write any function. Okay. So now, if you in the retrieve, if you like to add something, okay, if you like to add something, some number equal to, okay. So I'm going to add number plus sorry with some 5,000. Well, like that, you can perform some operation. Okay.
बापरे मॅडम प्रत्येक वाजेपर्यंत घेता की कारण आपल्याला लगेच सुरू करायचं सव्वा वाजता सुरू.
गुरुदक्षिणा देता येते.
Okay. Then you have to rewrite the code, compile it. So it's throwing some error in num. So I need to define that num, right? So let me define it as int num. Just give the value as 0 here. Okay. Now compile it. Then compile and run script. Then go to deploy. Then click deploy. Then come to storage. Then give some values. I'll just give 1,000. Okay, store it in the retrieve. It gives 1,000 because I'm not returning this number. I'm returning the num. Okay, I need to return this num. So like that, you can change the code and you can execute here. So let me define num also there. So I'll remove the integer num here. Deploy it. I need to deploy it, and then after deployment, you can store the value and check it. Okay. So this is the this other code. You can copy paste it if you want. I'll just share this code, the complete code, and share it in the chat box. So just copy this code and paste it in a contract. So here the contract name is financial contract. You have to save the contract name as financial. That's it. Okay. Rest is same thing. You can I just pass this code in the chat box. Whenever you find time, you can copy this code and create a contract called a financial contract. Okay, so once you create this financial contract, now I created three functions: deposit, get balance, and receive deposit. Like this, three functions I have written here. Okay, so now you see you could compile it. After compilation, deploy. After deployment, this is place where the financial contract have been created. Whatever code I created here, okay, you can copy paste it in the you can create a new tab and you can copy paste it, but save your file name the same name. So you see I saved it to the financial contract.sy. Okay, then you could see this is a place you can compile it, then you have to deploy it. Okay, so after deploy you can get the answers like this like deposit, receive deposit, and get balance. Okay, whatever, see, you can get balance and deposit. So whatever data you are giving it, it will function you created it will be populated as a tab here. That's all about smart contract. So you can create any contracts like this. Okay, the basic gas unit associated with Ethereum. So you might have heard about this gas Ethereum. Okay, what is a gas? Gas is a unit on the smallest type of the work. In the Ethereum network, gas is the smallest unit. Okay, the measurement of this gas will vary from unit to unit. Okay, so we will call them as a B unit. One B is equal to one. Actually, it is 1000 to the power of zero. Okay, anything power of zero we call them as one, right? So this is one unit. Okay, so if it is kilo V, it is to the power of 3. Okay, so it is 1000, like that it will go. Okay, so for every Ethereum gas we have a gas limit, the maximum limit, and we have to give the gas price. In order to identify the total transaction, we have to give this gas limit and gas price in order to calculate the formula. There was a formula associated with it. The transaction fees is equal to gas limit into gas price. Using this formula, the transaction fees will be calculated. This is all about your gas Ethereum. Okay, you might have heard about this Hyperledger Fabric as well, and this is also an open source project under comes under Linux Foundation. Okay, it's again a framework. So Hyperledger it's a framework. Okay, this framework will help us to create this blockchains account again. Okay, so it's a permissioned network. Okay, so you can plug and play. Plug architecture, you can drag and place. Okay, and it always ensures confidential transaction, and it is easy to get started as well. Okay, it's a Hyperledger. So we are just reaching the end of the sessions. Okay, the application of the blockchain, there are huge applications available in all the sectors, in digital ID, Bitcoin, IoT, online music, banking, law enforcement, payment and transfer, healthcare, voting, real estate. I just listed few. There are huge more scope is there for the applications of the blockchain. Okay, I just taken some use cases of blockchain. Okay, so when I take about in the supply chain, what type of blockchains could be supported? Logistic management and supply chain auditing could be done using this blockchain. Then in healthcare, we can create blockchain in healthcare. Okay? Even in the gold and silver trading, we can create this blockchain. Data handling, you can say data is just a small item, right? But there was a huge demand for it's called secured data, so you can handle data handling through blockchain as well. Okay, there was a huge demand for the blockchain for IoT. I think you might have heard this, had this session yesterday's. So blockchain for IoT, and managing your IP rights, IPR rights also you can do it with the blockchain. And economy, okay, ushering in sharing the economy 2.0, roles in smart agriculture, online voting, electricity trading, real estate management, and these are the various way you can give for security and authentication. Okay, and social networks also you can create the blockchain. These are some use cases you can try to explore yourself, and you can start your research work with this particular thing. Okay, so when I take a blockchain management in the supply chain management, okay, the impact of supply chain management. If you take, in the previous slide, I just broadly said logistic and supply chain. Inside supply chain, you can categorize where you want to incorporate that particular blockchain. Okay, for that I just brought this slide. Okay, so this slide will help us to understand the various wider range of application sector or domain where you could focus on this blockchain. This slide will help us to understand in the particular domain what are the various verticals we could explore it. Okay, so you can take it with the transaction statement. You can create a it's called immutable transaction here. Okay, audit transparency. Audit transparency you can incorporate. Then tracking social responsibility, accurate costing information, better shipping data, preventing compliance violation, prevents reducing human error. So these are the different places. Even automated purchasing and planning, automation, enforcing traffic and trade policy, food safety, reducing counterfeit goods. Okay, these are the various way. When I talk about supply chain management, inside supply chain management, there are various scope. Even if I take transaction statement, you can fine tune you can narrow down further what type of transaction statement settlement you can make it with respect to blockchain. Even if I take it as food safety, what type of food safety you can narrow down. Okay, so you can explore yourself by focusing on a particular thing. Okay, so this for a health sector, I just brought one more examples for blockchain in health sector, tracking drugs. Okay, and throughout the supply chain and securing the data. Okay, so from pharmacy, how this particular drugs is being transmitted to the patient. Okay, so from company, from who are the direct people who involved and indirect people who involved, insurance companies getting involved. Okay, and pharmacy and laboratory, you can check in which way you can in which path you can create a blockchain, and who is going to get a benefit out of it. Like that, you can create a blockchain for this in the health sector as well. Okay, and recently we observed that the Walmart is using this hyperledger. Okay, Walmart is tracking with the hyperledger. So they are saying that the provenance went from 7 days. Earlier they took 7 days to prove their tracking system. Now it is just 2.2 seconds is enough to track the it's called a product. Okay, food product. So now you see produce such as mangoes and strawberries and leaf greens, they're producing it. Okay, and even it is it's called applicable for the meat and the dairy product as well, and the multi-ingredient product as well. Okay, so this blockchain in this Walmart helps to reduce the time. 7 days, you just check where is 7 days and where is all about 2.2 seconds. Okay, so from mangoes in the US, the time needed to track the provenance went from 7 days to 2.2 seconds. So that was a proven hyperledger being used in the industry now. Okay, so I'll just end the session with my particular demo. What is our research work in this particular blockchain? Okay, so our blockchain technology is for supply chain, rice supply chain traceability system. Okay, so we in India, rice that to down to south. Consumption of rice is much more, so we started our process with the
सर
rice
सेशन
supply
मध्ये
chain
फीडबॅकची लिंक
traceability.
टाका ना.
Okay, so we just
हॅलो,
thought the
सेशन मध्ये
increase, the
टाकलं तर
drastic
चॅट
increase in the
विंडो.
price due to the middleman
हां हां,
has
चॅट
to be
विंडो आणि
eradicated.
सगळ्या
Okay,
ग्रुपमध्ये
that is the what's called purpose of constructing this blockchain into the system. Yeah. Okay, we created authentication, digital signature authentication using mobile and email verification. We created it, and we created distributed ledger as well to ensure the transparency and the traceability. So we build a solution, and we use a stack like Python, Flask, and HTML for front end.
छोटे प्रश्न
This is the
आहेत
implementation we have
त्यासाठी.
done using email verification and mobile verification as well. We have done in both the ways. This is a sample code which sources, and we have this API endpoints also to communicate this blockchain and to make some transparency in the blockchain. Okay, so the last uh, hands-on with you. Okay, so here Anders Brownworth again, he created a blockchain website. Okay. Let me check whether it is working. Yes. So similar to the earlier version. Okay, similar to earlier version. Here again, sorry, that already we there. We seen it. We'll see a demo for it. So now this is a demo. So it's saying welcome data. So you can create some. You can give some data here. Okay, so welcome to blockchain workshop. I gave welcome to blockchain workshop. You can type welcome all and delete the rest. Okay, so since it is a new chain is being created, Genesis block, there is no previous as. Okay, so now you can mine it. Now you see the color is changed from red to green now. Okay, now if you want to add some new block into it, okay, so you can add a new block. So now the second block will be added. Okay, so now this Genesis block will be the first block, and this zeroth block, and this will be the first block. Okay, so now you can create one more data. Like I just create a marquee here. Okay, so now you can create a network like this. So you can start the demo here. Okay, even you can add peers. Okay, so now Satoshi is here. You can add peers. By adding peers, you can add n number of peers here. Okay, like that you can send what's called, you can add blocks, and you can add peers. Then you can actually, it is asking for subscriptions. Okay, if you want to subscribe, you can subscribe. I think I have done most of my thing. So though we have a huge discussion with the blockchain, it does has the limitations. So the limitations of the blockchain technologies are the poor adaptation. Due to this, it is not much gains in the market. Okay, due to these irreversible process, immutable, okay, impossible to make revisions be needed. For instance, that again a big hurdle for this blockchain. And if the private key is lost, then lost is lost only. Okay, so it is difficult to recover it. Okay, and if there is a huge delay in the development. Okay, so because the consensus, if one particular consensus takes much time for authentication or authorize it consumes a lot of time. Okay, I think at least my learners could answer for this puzzle. Can you identify the various terms? What are the terms, whatever we learned it so far, as just brought it in terms of puzzle? You just put it in the chat box. What are the terms you could see in this puzzle? At least one or two terms, whatever we discussed so far, are there in this puzzle. Bitcoin and blockchain technology. In the last 2 hours, I was traveling with you. I was taking you in the knowledge of unblocking the blockchain.
मला एका पेजवर
Just
नावं
give me at
लिहून
least
द्या
one
एक
or
फ्री
two
बॅच
words you could see in
सगळे
cracking the
फ्री बॅच
puzzle.
मध्ये जेवढे आहेत तुमचे नावं लिहा रोल नंबर नका टाकू नावं
Else you can unmute yourself and even you can talk.
then screwed they came only for attendance block bitcoin blockchain बापरे 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 नहीं RTIT चा नहीं है
छोटी सी समझ में नहीं आ रहा था वो प्रॉब्लम वो स्टेशनरीची अमाउंट जास्त होते
माझ्या हातात
नहीं किससे बात करें हम आपसे ही पूछने आए थे ना कि भाई किससे बात करें क्योंकि
सब लोग नहीं जाएंगे अभी
No answer for this as well.
सिर्फ आईटी क्या है फिलहाल कि भाई हमको प्रॉब्लम हो रहा है ये सब
Okay, thank you. I got some answer.
आईटी के तो आए सीएससी के भी
Transparency, yes, Professor Gosavi, thank you so much. Transparency is there. Yes, Sital ma'am, Bitcoin is there. Good. Happy that at least I got two answers. Good, your answer is right. Bitcoin is there and transparency is there. I'll just show you and just wait for one more minute whether any other
हम ना कल थे देखो
transparency. Yes, the down row, the last row was
हाँ ना
transparency.
officially
Absolutely right.
हाँ ना और मैंने ना वो भी पूछ के आया कि भाई मैं वो भी पूछ के आया कि भाई
Bitcoin
क्या
also right. Any other answers? Okay, thank you. At least I got two answers. Thank you so much for your observation, and this shows that you actively observed all my content in this part 2 hours. Okay, so these are the other terms we learned about hash keys, secure, blockchain, resilient, nodes, traceability, SHA, immutable transactions, ledger, addresses, blocks. Okay, So these are the various terminologies which helps us to dig or unblock your blockchain. Thank you so much for your participation. So my special gratitude and thanks for the management and the head of the department, and particularly with the Dr. Priyanshi ma'am, who is the point of contact in establishing this particular session, faculty members, staff members, the technical team people who helped for this with the delivery of this session without any glitches, and the organizing team members, and finally the learners. Thank you so much. My special thanks to everyone here. So these are some references, and
मैंने ना
reach
नहीं
me.
कि भाई ज्यादा दे रहे हो
So
20 साल
I do have
नहीं
many technical videos. Okay,
मैंने
so
पूछा
in my
जो
social
भी है
media, I'm
किस
just
साइड से
having a
करने
many
लग गया
technical videos
तो भाई
like
970 है
using
और
many
वो स्टेशनरी
open
वाला
source
वो
tools
दे
like eSum, Scilab, RTool, and Node-RED. So these are the various open source tools I used it, and I demonstrated few sessions for it. That was actually prepared for students. Now it is being shared there. If you like to have it, you can see over there. Thank you so much. If you have any questions, I'm ready to take this question now. So I can share my email ID and number channel in the chat box. Professor Gosavi, thank you so much. Priyanshi ma'am, thank you. Sonal ma'am, thank you for your nice feedback, nice session. Thank you. Thank you so much for your lovely feedback. That is the only takeaway I can take it from your end to my end.
जैसे
Thank
पिछली
you.
बार ना जैसे
So if
ऐसे
you
ही
have
गए
any
थे हम लोग
doubt,
तो
you can
गंदी
ask
अच्छी नहीं
me.
लगेगी
So I can
और फिर वो
open my
बोलेंगे तुम अकेले आए हो सहमत ही
session
रहे
for another couple of
फिर
minutes
हमने क्या किया था
to
सबकी
handle
साइन
your
ली थी
doubts.
कि भाई सीएससी की पूरी साइन आईटी की पूरी
Ma'am, I would like to ask one question.
Yes, sir.
What will be the impact towards the market in financial services and beyond?
What is the impact of?
Towards the marketing in finance services and beyond.
So now financial sectors are it's gaining its market because of this, because you're creating an immutable transactions, right? The scope is huge, but the deployment takes time. So you even you can explore yourself how you can create a different consensus algorithm. Okay, the scope in the market in the financial sectors are now the existing consensus algorithms are a little bit complicated. So you just try to check whether any new consensus algorithm you can create it a lightweight consensus algorithm. It should be authenticated and it should be lightweight as well, so that you can gain the market in the financial sector for this. Because of this only, there was a
तो वो
little bit
WhatsApp पे
lag
वैसे
in
नहीं
this
प्रॉब्लम होती थी वो
deployment of the
दिक्कत होती
blockchain in this sectors.
तो कुछ होता ही नहीं है इसमें
One more there is, ma'am.
तो चार्जर तो कुछ हो रहा ही नहीं है क्योंकि पिछली बार भी गए थे
What are your recommended for individuals or businesses looking to get started with blockchain technologies?
Is you
तो
can
सबसे
check
पहले मना किया फिर क्या करना
the
होता
domain. First you identify the domain, in which
है
domain you're, because we are all in the
तो
academic
सभी
academic
स्टूडेंट के रिप्रेजेंटेटिव करके
sector.
आए हैं ऐसे
Okay, we
कुछ
are in the academic sector. You can give many
उसको प्रॉब्लम है
productions
हम
towards the
सीआर आपके पास
requirement of
आए
the
आप बताओ
industry. Okay, so wherever there you require security. Now nowadays the lands,
हाँ जितना मतलब
the
फिर
land
उतना अच्छी बात है
registration,
वो
land registrations are just going behind for the blockchain. Like that, wherever you feel
वो एक
that
छोटा सा
a
और है
proper security is to be
आप देखते
ensured,
हैं कैसे
and wherever you like to avoid middleman transactions, like we have taken agriculture sector is one sector where
वो
middleman
जो
transactions is
अटेंडेंस है
high.
ना
Okay, even you
दिन में
check
4 दिन
with
निकलती है इसकी
delivery
तो उनकी
of
रहती रो गई है तो
drugs.
आज
There
सीरियस
the middleman places
नहीं
are high. Okay, even
उनका
in the
यार
property sector,
उनका
middleman
नहीं है वो
rules are
आते
very
हैं
high. Okay,
बट बाद
wherever
में क्या
you
जीरो
feel
होती है
that in this
फिर
particular
वापस
domain
अपना साइन
middlemen are playing a vital role, there you can bring this novel application, so that that organization or that industry could adopt your.
एक ही दिन का था मैं एक ही दिन का ठीक है देख लेते हैं जैसे थैंक यू
Thank you, ma'am.
Thank you all. Shall I just wind up the session? Shall
सॉरी
I log off?
हाँ
Thank Thank you so much, ma'am, for your precious times and telling us about the unblocking the blockchain. We got to learn a lot from today's session. So, on the behalf of our institution, I would like to express our heartfelt gratitude for accepting our invitation for today's session. And in closing, let's carry forward the spirits of learning and innovations inspired by today's session. Thank you. And ma'am, also please, participants are asking for the PPT. So can you please share the PPT for our participants?
Okay, I'll share to ma'am, and ma'am could and it's called distribute everything.
Thank you.
910
Thank you.
नुसार इथं लोड करेल ती.
Thank you, Professor Nicholson. Thank you so much.
आपण 310 वरून डायरेक्ट 700 खूपच जास्त झाले ना. हे हिच्यामुळे झालंय सगळं. मी नाही म्हणत होती, मी पूर्ण त्यावर बोलली होती की नाही, काही गरजच नाहीये ना, मुलं लिहितायत ना मॅन्युअल टाईप तर टाईप काय